Welcome back. Welcome back to the course Privacy and Security in Online Social Media. I hope you're enjoying the class. What we will do now is actually the week 5 part 2. Okay. So the content that we were continuing to do was on the fake news. So week 4 was fully on fake news, fake content. What are the different types of fake content? How can you actually detect it? What are the methods to detect it? All of that we saw. So we are continuing to look at the same content about misinformation, disinformation, malinformation, all of that in this week also. This week fully also will be on fake content. But by end of the week, I think you will have a good appreciation for solutions to build, why these solutions actually don't work, right? Some of the things as part of these kind of courses that you should learn is that what is possible is for sure you should know, and some of the things that you should know is what is not possible. Right. So one of the common things about fake news, and it's going to be extremely hard to do it in real time. Very, very hard to keep in pace with malicious users' actions, right? The quickness in which they can create a fake content, a fake account to do the post, the time in which they will actually get the content generated on a blog looking very similar to the social media post, fake looking website, all of that is actually getting shorter and shorter. Interestingly, the skills needed is also reducing. Right, is also reducing. There used to be a nice graph in at some point in time from Software Engineering Institute, where they showed that the type of attacks has been increasing, right? For example, initially the attacks were of the sort of password guessing. That's the first type of, so to say, cyber crime attacks that happen. Password guessing to get internet access. Right? So, and particularly the organization used to be AOL. American Online used to give the initial first, so to say, public internet access. And guessing the password to get internet access was the first kind of attacks that was going on. And of course, this line has been like password guessing, phishing attacks, semantic attacks under here, DDoS attack, DOS attacks, right? All of these has been going on like this. And the way it is growing is that number of times the attacks happen is also very high. That's what this growth is. Interestingly, if you look at the skill level that is needed to do these attacks, it's been actually going down like that. Right? If this was the number of attacks, and if there's another scale here, which is what this graph is referring to, is the skills level. So that's actually reducing. Right. So for password guessing, at some point in time, you needed a lot of skills to do that. And today, if you see that you want to do a phishing attack, I think it's not at all hard to set this. And particularly, this is becoming, this is the case is because the environment in which this crime is happening, right? These are all now has become organized crime. Which is, you don't, for let's say for phishing attacks, if you have to set up, you need a fake website for which you need a lot of domains. Then you need a curation of email IDs, right? I need to send emails to people. That's where, that's how I will actually get you to look at my phishing link. Of course, email IDs, Twitter handles, all of that is there. Then you need to email server or your social media, social accounts. Right? All of this you need to do a phishing attack. And when it lands on a page, this domain needs to have a pages, which looks like a real page. And then when they give the username password, it has to be stored in a server or something. And then something can be done with that. So all of this are different parts of a phishing attack. Earlier, let's take a decade before or 15 years before, when you have to do this phishing attack, you are actually generating each of this. You should be creating the website. You should be curating the email address. But today, that's not the case, right? It's all organized, which is, that's like, it could be probably as a crime as a service. Right? So you just pay them, pay a server saying that, look, I need 100,000 email address. I need phishing websites of ABC organization. I need these many tweets to be posted about it. You just give the money and then the service will take care of doing all of it. Crime as a service, right? It's not new, right? I recently watched some Tamil movie where I think this is age old, right? You give some money to people to get attack somebody, to bribe a place, to rob a place, all of that, right? So if you think about it, these have been there for long time. And the current scenario that we are in is just making these to do much easier and harder to actually attribute to who did it. So that's what the problem is right now. Okay, I hope you got a sense of what's going on, which is what I was trying to get across was. What is possible and what not possible is what you should keep a watch for. The skills required to do many of these attacks are actually reducing over time, which is 20 years before you need to you should have been an expert to do, let's take a phishing attack. Today, you don't need to be. That's the point. Okay. Coming to the fake content, right? In any case, please remember all of this is embedded in the content of the course. So it's okay to do a little bit of a digression on some topics and coming back to the fake content itself. Right. What we're going to look at now is content-based fake news, right? Deduction, which is focusing only on the content. Within the content, you can think of multiple, right? We will actually look at the other parts also, which is multimodal methods, multimodal features. Currently, we will start with text-based methods. So text-based methods, you can think of it as initially, I've been repeating this over the course, which is in social, you generally get access to text, account, profile, network, images, which can be embedded in text also. Text meaning the content. Generic text features, which is semantics of the post, syntax of the post, which is actually the language itself. Semantics of the post, what is being discussed, lexicon, which is dictionary, vocabulary, discourse, what kind of so to say stance are they having in the topic that is being discussed, what kind of sentiment are they having in this discussion. All of that could be cut down from discourse, right? So that's the general generic text features that one can draw from the social content. Let's getting to the next level, which is latent text features. Text features, as meaning it could be just the simple number of times a word is appearing, right? If you go back and look at this, this could be thought of it as just a frequency count of the words that appear in the post. But now we'll actually look at something more involved. Latent text features, which is word embeddings, right? Word embeddings are nothing but take any word. For example, this is strawberry, this is mushroom, I guess, this is lemon. Take different words that you want to represent in a multi-dimensional space. Each of the words, each of the concepts to be a vector, and that vector can be used to find the distance between two of the words, two of the concepts, and the distance can be used for making choices. That's the idea for word embeddings. Every word is represented as a vector, and these dimensions can be very different. Something can be 2, 3, multi-dimensional space you can represent. If you do this for the words, right? So for example, now you can, if these are represented in word embeddings and they are in this distance for a particular, let's take the citrus, the amount of citrus in the fruit is this level of distance, let's take, right? In the word embeddings, you have, is this a citrus fruit or not? Citrus levels in the fruits of these features being captured in the vector, then the distance between strawberry and lemon is so much. Right. One can start using this distance to find out whether these fruits are close enough in some characteristic, growing under the soil, growing above the soil, you need a lot of water, some needs less water, all of these features you can think of. Now, sentence embeddings, right? Same thing, same idea as word embeddings. Instead of words, now you think of a sentence as a vector. And then the last, you think of a document as a vector. Each document, meaning one can have multiple ways to come from here to here, here to here. Right? The way to think about it is that multiple words can be put together in a sentence, and now you create a vector of all the words that are there in a sentence, and that becomes a vector. Same thing, document vector, all the words, all the sentences in the document put together, create a vector, and that becomes your document vector. Right. There are methods to do this, meaning we don't have to implement this from scratch every time you want it. So here are the different methods in which already existing open source methods you can actually try. Word2Vec, LAV, and BERT are the ways by which you can create word embeddings of a given text, given tweet, given post. Sentence BERT will give you sentence embeddings. Doc2Vec will give you document embeddings. Right? All of these becomes very, very handy when you actually do the analysis of the content to find out whether they are going to be fake or not. So that is latent text features. Let's look at a couple of sort of say work where we used these kind of features to detect fake content. So this is towards news verification, deception deduction methods for news discourse. Right? If you look at it, it's using multiple words that we have already said. Discourse, deception, I already said many times. Verification is all the part about fake news, veracity, deduction methods also I said. So the goal here is deliberately deceptive fabricated news creates false conclusions in the reader's mind. Truthful, authentic news matches the writer's knowledge. So that's the hypothesis that they had, which is deliberately deceptive, fabricated news creates false conclusions in the reader's mind. Basically, if you look at content that is deliberately changed, it gives a false impression for the users reading it. How do they tell the difference between the two in an automated way? Can users use tools, which is what finally the ultimate goal of people like you and me should be, to develop tools which can help end users like your mom and dad to figure out a difference between real and a fake content. So they use rhetorical structures in discourse constituent parts and their coherence relation. I'll tell you what these are, but the goal is that they're using the content, they're using the text, because that's the section that we're looking at. We are looking at text-based methods. Later in the week, later in this part itself, we will actually look at beyond text-based methods. Right. So here, if you see, I mean, again, the goal of the class is not to get in the details of the paper and find out what solutions they have, but the goal now is, look, there are methods in which there are research in which text is being used to make a choice. Here is another way that they've used, which is stylometric features. Paper investigates syntactic stylometric for deception deduction, which is how the sentences are created, right? So syntax of parts of speech, right? Parts of speech. Parts of speech is one of the syntactic features that you can actually generate from the content that is given to you. And then lexico is your unigram, right? Bigram of all of the text. Unigram is nothing but, let's take unigram at the level of words. You're basically counting all the words that are in the text. Let's say cricket, playing, IPL, all of that. Bigrams will be 2 words. Cricket, match, playing well, IPL 2023. So these are 2 words, right? So 1 word, 2 word, 1 word, 2 word, 1 word, 2 word, right? So you can do n-gram in that sense, right? So this can be n-gram. So the idea is that, can you use these parts of speech and unigram and bigram and n-gram to make a choice whether the content is real or not? That's what this paper does. Features driven from the context-free grammar parse trees, which is representation of the content that is given to you in some tree structure, consistently improve the deduction performance over several baseline methods only on shallow lexico-syntactic features, right? So if you represent the content in some embedding space, in this case they are using it as parse trees, then the methods are more useful, perform better in identifying the content to be false. Right? Again, keep the goal as understanding how text is being used. Automatic deduction of fake news is another work where, again, text is being used. If you look at n-gram, if you look at psycholinguistic features and punctuations, all of this is being used to find whether the content is real or fake. So in n-grams, the content used is, we extract unigrams and bigrams derived from the bag of words representation of each news article. To account for occasional differences in content length, these features are encoded as TF-IDF. TF-IDF, I think I mentioned some time back, which is term frequency inverse document frequency, which is a measure of the words that are given to you in a document. Right? So that's what unigrams and bigrams are used here. Next, psycholinguistic features. We use LIWC. LIWC is a tool which actually takes input as a text. Let's take paragraphs from a blog, paras from blog, or tweets, or Facebook posts, all of this. It takes that as an input, and it actually gives you values on different types of content that is available in the text that is given as input. Right? We use lexicon, LIWC lexicon to extract the proportions of words that fall into psycholinguistic categories. LIWC is based on large lexicons of word categories that represent psycholinguistic processes, positive, emotion, perceptual process, summary categories, as well as parts of speech categories, articles, verbs. So there's like many, I think there are like 35 or 37 different categories like the psycholinguistic process. Like this, there are 37 categories which can be used to find out what the content is in the using LIWC. Last one is the punctuation that they use, which is previous work on fake news deduction, as well as opinion spam, as well as an opinion spam suggests that the use of punctuation might be useful to differentiate deceptive from truthful text. Interestingly, these are some things that has been done in traditional problems of, let's take phishing, all of that also, which is number of times punctuations are used, number of times smileys are used, number of times colons are used, all of that. We construct a punctuation feature set consisting of 11 types of punctuation derived from linguistic inquiry and word, which is LIWC again. This includes punctuation characters such as periods, commas, dashes, question marks, and exclamation. So there's also this belief that, or it's also quantitatively shown, I've done it myself, where in terms of phishing email or messages, there's actually a lot of spelling errors. Right? There are spelling errors, and same thing, punctuations may be missing. Punctuations may be missing. That's the idea here, which can be very, very useful feature to decide whether the content is real or fake. By no means this is comprehensive about text-based features. Because I think given the nature of this topic, given the body of knowledge that is generated on this topic for, let's take, last decade or so, is humongous. I don't think so. I'm pretty sure we can easily create a course on just fake news deduction. I don't think so. There should be any problem in creating that course. That much of content is there. The purpose of this course is to help you understand some of these problems. So we decided to keep fake news for 2 weeks, and particularly looking at the social data, right? All of that we're talking about is in the space of social content. Image-based features. I think it is like a no-brainer, right? In terms of why we should be studying image-based methods. Today, if you look at your timeline, your feed, 90% of the posts, at least in my case, that's the way I'm guessing it's also in your case. And this is also another reason why platforms like Insta has become more popular, because of the image content that it is generating. Right? So even in your Facebook, even in your Twitter, if you see huge amount of content is getting generated only using images. Right? I don't know whether any of you are following my post. I'm sure you will see. I don't even remember any post that I've done in the last, let's take 3, 4, 5 years, probably 3, 4 years, had only text in it. Very rarely I would have done only text post, right? I'm not a I'm not a representative user of social, but I'm guessing that you will understand why images are important. Again, to show you some work, not a representative work, but just to get you understand what kind of ways, methods people have used. This paper explores the key role of image content in the task of automatic news verification on microblogs, which is like a Twitter. The experiment is performed on a data set of 50,000 tweets and 25,953 images of fake and real news events. Right. So you take the tweets, you take the images, you do some analysis with the images, and make some prediction that whether this is real tweet or not. Images in real and fake news example is a very interesting observation, right? If you see, images in the real news are much more diverse than those in the fake news. Right? This is fake. All of them look the same, whereas real, if you take an incident, the real news has more diverse set of images. I told about emojis, and if you think about it, emojis are also a great feature to find, right? At least we have used it in the past, which is very rarely a fake content is going to have a smiley. Very rarely a fake content is going to have emojis of different types, right? Right. All of this is not going to show up on a real post, real content. This will show up on real content, I'm just saying it will not show up on a fake content. This, they showed it through images. Image variety is very small in fake versus in real. So interesting, this is again an interesting graph if you look at it, which is images have discriminative visual distribution patterns, fake and real news event, but how to describe image distribution based on the visual content. So we saw, right, lots of varieties there in the real tweet. So this graph is, x-axis is the number of tweets and y-axis is the number of images that it has. Right. So if you see this part, right, the interesting thing is the plot image to tweet ratio, right? Number of images are higher for real, right? For real, if you see, there's a lot more in this part, there's a lot of circles, black circles here, right? Ratios are much higher. The image to ratio of real news tends to be larger than the fake news. Given the small number of tweets in news events, real news events tend to contain more images than fake news. And if you see here, lots of fake news, lots of fake news has the ratio of images per tweet being lower. Ratio of images per tweet is much higher over here, generally over here also. Right. So that's what you want to keep in mind. Number of images that are posted for the event, for a particular event, real news has the ratio being more. Here's another one. They created this thing called as visual clarity, which is design distribution metrics, visual clarity score. Images in the real news events are from various sources, and images in the fake news events are from limited sources. Connecting to the first slide that I showed you in this one, right? That's the visual score. Visual clarity score measures the distribution difference between the two image sets. Thus, the bigger the score is, the more distinct the target news is. Images in real news events are more general and have lower visual clarity score. Right? Real news has lower, so if you just compare this, real news is much lower compared to a fake news. That's the right score. The visual clarity score for fake news images is more as compared to the real news, which these two are just saying the same thing. Right. So therefore, the idea is that visual clarity score is lower for the real content. So this will help you. I mean, again, keep in mind, these are different metrics that people have created. I think the goal for me is to introduce you to these different metrics, get you understand that these metrics can be easily, for example, right, you can easily program this into a tool, right, if you really want, and if you believe that this metric is actually a good one to help find a fake or a real. Here's the next one: fighting fake news, image splicing detection via learned self-consistency. So this idea of image manipulation has been there for a long time, right? So you take an image, you splice it, you make some part of the image much larger, you cut some part of the image and reuse it somewhere else. All of this you can do. The paper proposes a learning algorithm for detecting visual image manipulations that is trained only using a large data set of real photographs. The algorithm learns to detect and localize image manipulation. The goal for this algorithm was to localize the image manipulation, which is to find the parts the image has been manipulated. And the reason why this is important is that you can use this as an input to the fake news deduction module. Right? You have a larger module in which you want to, the input is tweet, output is fake or real. Inside that, one of it is image analysis, which is the part that we are actually looking at right now. The algorithm uses the automatically recorded photo EXIF metadata. So this is an interesting information that is available in a photograph. So when you take a photograph, you should probably try it yourself. Take a photograph in your camera, go to an online EXIF reader, dump the picture on the EXIF reader and see what all it actually provides. Next slide has some details of an EXIF. EXIF is nothing but it will give you a date of taking the picture, sometimes location of the picture, what camera was it camera used for taking the picture. Like this, you can actually get some details of the picture itself. Very interesting thing that the social media does is that when you upload this, also you should try. I'm saying all of this, you should try that. Please try and post it on Discourse if you find anything relevant, interesting, and something that you are excited about. Interestingly, when you upload an image to a Facebook, let's take a 2 MB file, 2 MB picture, upload it on Facebook. Now download it and see the size of the file. It will be super small. Same thing in WhatsApp. WhatsApp though, this will make it like KBs. No? If you look at the picture that people are sharing to you, download the picture and see the size of the picture, you will realize that it's in like few KBs, 30 KB, 40 KBs. I think social does in like 100. At some point in time, they were like 300 KB per picture on Twitter. Algorithm uses automatically recorded photo EXIF metadata as supervisory signal for training a model to determine whether an image is self-consistent. Right? Whether it's self-consistent, that is, whether a single image pipeline could have produced its content, could have been produced by a single imaging pipeline, right? So the idea is that no manipulation is done on the image. Here is a great example. I think next 2-3 slides will help you understand So here is a EXIF, right? Camera make, camera model, color space, all of that is given. EXIF image width, image length, flash, focal length, white balance, comprehension per pixel, date, time, original. Right? Some of it I said earlier in the last slide. One of the most common phases of creating creative fake news is splicing together content from two different real images. Look at this. This is a real image. This is a real image. But then they merged it together to show that it's actually a this is how it looks, but that's not a real image at all. And you can, so if you look at this and this, these are EXIF of these two individual images. Patches from a spliced image are typically produced by different imaging pipelines, as indicated by the EXIF data, EXIF metadata of the two images. So if you take the EXIF image of this, it's going to be some combination of the other EXIF data, which can be used to find out whether it is spliced or not, whether it is manipulated or not, right? Please understand, this is a method they're using to find out whether it is real image or fake image or manipulated image for now, using EXIF. There are other methods to do also, right? The model takes two random patches from different images and predicts whether they have consistent metadata, right? So that's what they do. They take this part of the image, this part of the image. Of course, they use all the CMEs and ResNet 50, and then they finally predict whether these two parts that are picked different predicts whether they are consistent metadata, right? If it's the same image, they should probably have the same metadata. If it's different images, they should probably have different metadata. I hope that gives you a sense of the aspect of text and the image side. Now what we'll do is we'll merge these two together, which is multiple modality based methods, multimodal. Also you can keep multimodal based methods, which can actually help detect fake content. Like classic papers, right? I think this paper, next paper, or like the base papers or the papers that was the initial movers in this idea. This one is Ian. So this interesting is that they do this part of event discriminator and the fake news detector here. Event discriminator is a way by which they have actually find out what are the features using which you can actually detect the event in the ones that you're analyzing. Remove those features, which is that if you're collecting about a protest, remove the features of a protest from the data and then look at whether it is fake or not. That's what this part would do, right? So I'll show you what I meant now. So event discriminator, the role of the event discriminator is to remove the event specific features and keep the shared features among events, right? That's protest, remove the protest. Cricket match, remove the cricket match. And so now when you do that, the strength, again, if you look at it, it is actually taking Reddit, some text it has, even the earlier slide is same thing. It has some text, it has some image, it is having the image pipeline, this is having the text pipeline. Their text features are created, image features are created. It's actually concatenated here. Once the concatenation is done, then we look at the features, then make a choice of what are the features that are used for detecting an event, remove those features, and then use only the rest of the features to detect whether it is fake or real. Okay. Same structure, multimodal. If you look at it, text, image, all the text features, all the image features, it comes here. The one thing that this had is that it has a latent vector here, which is created as a vector, and then now you're going to say that decoder is used here in addition to the methods that we saw earlier, and then fake news detector is kept separately. Let's see what this does, right? Correlations across modalities. So you want to make sure that you understand how to merge, how to put the features that you're getting from text and image. That's the part this is doing. The model learns shared representation of both the modalities. It learns from the input of images, input of text that is given. Model is trained to reconstruct both the modalities from the learned shared representation and thus discovers correlations across modalities. So essentially the goal is that I want to know whether the features that I've given in the text and the features that I've given in the images are helping me to decide whether it is fake or not. Okay. So going along the lines of the multimodal itself, some of the work that we had done at some point in time got very, very good attention in terms of the nature of the work that we did and the problem we were trying to solve. This is actually a current work also by one of a PhD student where we are trying to say that multimodal information can be used to find fake news. The difference that we were making is that incorporates the power of the language models, right? LLMs, at least now, are becoming more and more popular thanks to ChatGPT kind of efforts. Language models, bidirectionally encoded representations from transformers, which is the BERT, to incorporate contextual information. BERT we used so that it can actually capture the contextual information from where this text or the image is coming. And of course, in this also there is text, there is image, both together, that is used for detecting whether it is fake or real. Features are learned from VGG. Of course, images are analyzed VGG, pre-trained on ImageNet dataset, and then representations from both the modalities. So if you look at the structure, right, structure is typically always same: text, image separately. You do something with this, you do something with this, you bring it together, you put them together and then take it and do some part of fake news, do some part of decoder or other methods, and then you detect whether it is fake or real. Right? Same structure that can be maintained to do this. Representation for both modalities are then concatenated together to produce the news representation. So here the news vector is nothing but the multimodal pod. Which is, it has both text and images finally used for classification. We also enhanced this by pre-trained ExcelNet and improved the way that the framework was designed earlier in Spot Fake and made that the method was detecting given a content which is multimodal better than Spot Fake. Right? Again, images, text, very similar methods were used, but here we were able to generate better results. So that is what generally fake news deduction methods are: text, image. Of course, you can embed, network, all of that. But for now, let's understand only the text and the image part. Let's move on to see how in the past, Twitter particularly has been used for detecting fake news. Again, not a representative sample, but definitely gives you a history of that area. Next few slides are some work that was phenomenally influential in terms of thinking about this problem itself. This paper is definitely one of the best papers that you should definitely read this paper if you're interested in this topic. Take a look at the paper. We can actually do a paper reading session at some point in time if you're interested in some of these classical papers in this area. This paper proposes an automatic method. So essentially what this paper does is it says that, look, a topic is there, a blast happens, flood happens. Can we take the tweets from these topics, collect the tweets, and find out whether the topic is real or fake? There are signals available in social media environment itself that this is one of the classical papers, and that's why if you see the word credibility is here, the paper published in 2011, that's like 12 years before, and it kind of helps using different features of Twitter and for making the choice, right? Twitter, of course, has message-based features, user-based features, topic-based, and propagation-based. Length of the message, whether or not the text contains exclamation. I told you earlier, right? Emoji can be added now for this. Emojis probably may not have been that popular at that point in time. Number of positive, negative sentiment words in a message. Tweet contains a hashtag if the message is a retweet. Registration age, number of followers, number of followees, number of tweets the user has authored in the past, fraction of tweets that contains URLs, fraction of tweets with hashtags, fraction of sentiment, positive and negative in a set, depth of the retweet tree, right? So, for example, U1 does a post, U2 retweets, U3 retweets, and U4 also retweets. But U4 has a U5, U6, U7, whereas U3 ends there, right? Depth of the retweet tree, number of initial tweets of topic. It's been observed that this influences the impact of the message, which is number of topics, number of initial tweets, right? Number of initial tweets of a blast that happens, right? If that itself is huge, then there is going to be larger impact impressions of that content. So this first work by Chato looked at Castillo. So, right? So Castillo looked at the topic as fake or not. Then Aditi said that, look, I think topic can be fake or not is good, but I think it's going to be very hard to decide whether a topic, right, a cricket match, how do you know whether it is fake or not? Right? So we started looking at a tweet level. That's where this work comes in. Analyzes the credibility of information in tweets according to 14 high impact events in 2021. So we said that, look, we should actually start looking at this as a serious topic. We analyze these events. These are the number of tweets. These are the topics that we use. These are the description of the event. We use all these features of the tweets that was done by Castillo. Use that for multiple events to find out whether we can actually predict a given tweet from different events, they are fake or not. Same set of features as Castillo showed. We started adding emojis also. During high impact events, there's a sudden rise in the activity over the internet. That's the natural thing that happens. Generally, this is, let's take tweet, and suddenly if you see a blast happens, there may be some things like this, and then somebody dies, politician or some senior people, then the graph can look at something like that. It spikes and there is things go low at, meaning normally this is what the behavior is in some sense. People log on to social, so the news, right? News people are using it only through social now. They found 30% content about the event provides situational awareness information about the event, while 40% was spam. So large proportion of the content gives you information about the event, but some proportion is actually fake also. So then this was a body of work that Aditi ended up doing, which is taking up events like faking Sandy. This was Hurricane Sandy. Then there was Boston Blast. right? Those days, this was very popular about taking an event and doing some analysis, characterization and all that. It's not very common these days, but a decade before, that's how it was done. The aim of the paper is to highlight the role of Twitter during Hurricane Sandy in spreading fake news. The paper performs a characterization analysis, temporal, social, and influence patterns for spread of images, right? So it is characterization. Couple of things that came out of this work is probably very interesting, which is we got these access to these kind of images which are not real at all, and using location-based content, which is your geotag tweets in this case. We could know from where the tweets are coming, but location can be got 4 different ways. Geotagged is one, my profile is another one. I've already covered this in the course, but I'm just reminding you about it, refreshing your memory. It can be gotten from the profile. It can be gotten from when I created the account. And it can be gotten from the content of the post. So something that this paper did was they analyzed, right, the hours since the first tweet. That's the x-axis, number of tweets that are posted. Is on the y-axis, which is to show that after 10, 11 hours to about 15 hours, large content is getting generated about the event, right? So of 10,350 tweets that comprises of fake images, URLs, about 86% were retweets. That is, only 14% people posted original tweets that contain such URLs. So the interesting thing about this URLs and how much of it is real, how much of it is created, and how much of it is retweeted is actually an important ratio to keep in mind, because I think events like cricket will generate a lot of tweets but less of RTs, right? This is more, this is less. Whereas let's take a crisis will create more of RT but less of tweets. Right? Only few people are involved in the tweet. Only few people are have access to actually the crisis, road accident, floods, bomb blasts, right? These kind of events, if you think about it, information is available only to few people, which then gets spread a lot because everybody is interested in the topic, right? So fake URL spread spikes at 12 hours. After the introduction of the URL in the Twitter network. This is about one URL being posted. It's a great way of studying URLs because it's kind of helping to narrowly ask the question about URLs. It's easy to find out whether the URL is in the post or not. Analyze the spread of these pictures, URLs 1 hour before and after the spike. So interestingly, what the question that they were were studying was, look, these images are posted, these URLs are images. Can we actually study what's happening before and after some point, so that we can tell something that, look, here is something that here is a handle that we should be actually careful about when the content is getting spread. Construct the reply and retweet graph. Next slide will show you this. For the tweet sharing these fake picture URLs on October 29th, 21 to 22 hours. Right? So this is 21 hours, this is 22 hours. There are many interesting observations that you can find if you just look at this, right? 213-401-443 is the user which is more popular at 21 hours. If you look at 22 hours, the popularity is none of them. These users are not even any one of them. none of these users are this user, 443. The point is that the content gets generated by somebody and the spread can happen by somebody else. Right? Look at this user. This user is so influential or responsible for spreading this content heavily. Here is another one. Here is another one. Right? So there are only a few users with very high degree. That is, only a few users result in the majority of the retweets. Right? Spread of fake pictures URL, the number of the node in the user ID of the Twitter, the figure shows that the fake images became a viral very fast because 21 to 22 hours, there's like huge chunk of content that was created or retweeted within an hour. There was tremendous growth in the number of people tweeting it. It all depends on the content. I think it depends on the, so to say, the event, a particular content in the event. Other few observations which are very interesting is that 30%, top 30 users resulted in 90% of the retweet of the fake images. Right, so this is the 30 users. They are the ones who are actually posting the 90% of the retweets of the fake content, which is, again, this can go back to our Pareto principle, 80-20 principle, all of that. Right? So to say that the small set of users who are doing the most amount of retweets of the content. Right? So that's the end of week 5, part 2, where our goal was to introduce you to different content that is available, how to use that content to make methods for detecting fake and real content. Hope that made sense. Again, if you're interested, please read these papers of Castillo, Aditi. Any of the papers if you read, I'm happy to actually chat with you to walk you through the paper and give you some more details of the papers. Also, what we'll do in part 3 is to actually look at WhatsApp and fake news data sets that can be generated. Basically, look at other methods of other parts of fake news also. Thank you for listening.